Hi guys, Audrey here, and this is a JAC capsule on factoring. In this video, we're going to factor a polynomial by factoring out the greatest common factor. Let's get to it. All right, so your goal for this video is going to be to factor the polynomial that you see by first factoring out the greatest common factor. If you think that you can do that, great. Pause the video, do your best. If not, let's do it together. So our first step when we went to factor out the greatest common factor was to think of each of the terms in terms of their prime factored forms. So in this case, let's identify the terms. We have 90x to the fifth y to the fourth. We have 45x cubed y to the fifth, 30x to the fourth y cubed, and 15x cubed y cubed. So the x to the fifth, y to the fifth, x cubed, y to the fifth, we don't really need to think about that in terms of its prime factored form because it's pretty obvious. X to the fifth is 5 x's, x times x times x times x times x. So we just have that x 5 times. So really, we want to start by thinking about the 90. Now, the good way to do this is I immediately see that 90 is divisible by 3. 90 is equal to 3 times 30. So I'm going to write 90 as 3 times 30. 3 is a prime number, so that's a great place to start. Then the 30 is also divisible by 3. So I'm going to keep writing. This is 3 times 3. 30 divided by 3 is 10. So 3 times 3 times 10. But 10 is not prime, and 10 is equal to 5 times 2. So we're going to rewrite this as 3 times 3 times 5 times 2. And now we've thought of 90 in terms of its prime factors. Now I'm going to do the same thing for 45. I immediately see that 45 is divisible by 5. And so 45 divided by 5 is 9. But 9 is not prime and is in fact 3 times 3. So this is 5 times 3 times 3. Now we'll do the same thing with 30. We've already done it because we saw it inside the 90. We saw that 30 was equal to 3 times 10, which was equal to 3 times 5 times 2. And then for the 15, 15 is just 5 times 3. All right, so we've written them out in their prime factored forms. And now the next step is to identify what factors occur in every single term. So if I wanted to, I could rewrite this polynomial where I write 90 as 3 times 3 times 5 times 2, but it's not necessary to do that. I can just sort of think about it. So I'm going to start by looking at that 90 and saying, hey, look, 90 has a 3, 30 has a 3, 45 has a 3, and 15 has a 3. So that is a factor that all 4 of those terms have in common. It's going to be part of my GCF. So let's write GCF is equal to 3. But that's not the only thing that's part of the GCF, because I go to the next 3, but 30 does not have 2 3s and neither does 15. So we're not going to take that for our greatest common factor. But then I look at the 5 and I'm like, hey, there's a 5 in my 90. There's a 5 in my 45. There's a 5 in my 30, and there's a 5 in my 15. So that will be part of my greatest common factor. Now, that 15 has 5 times 3, but it doesn't have any other prime factors. So I'm not going to have any more numbers as part of my GCF. So then I'll move on to the x to the fifth, y to the fourth, and the x cubed y to the fifth. When I'm doing variables, I always want to take the lowest power for the GCF. Always take lowest power for GCF. And that is even if that power is negative or fractional. Even if negative or fractional. We don't have to worry about that in this case, but it is useful to think about. We're always taking the lowest power. So in this case, I have my 90 has x to the fifth, 45x cubed, 30x to the fourth, 15x cubed. The lowest power that we saw there was 3, so that's what we're going to take, that x cubed. And then we'll do the same for the y's. Again, we want the lowest power. So we have y to the fourth in the first term, y to the fifth in the second term, y cubed in the third and fourth terms. So again, we're taking that y cubed. So the GCF then is 5 times 3 is 15, x cubed, y cubed. Now my next step is to write that out front. So we're going to rewrite this polynomial, 90x to the fifth, x to the fifth, y to the fourth, minus 45x cubed, y to the fifth, plus 30x to the fourth, y cubed, plus 15x cubed, y cubed, equals to 15x cubed, y cubed. I'm going to open up some parentheses, and remember, we're dividing each term by our greatest common factor, which can be easily thought of by saying, what did I take away in the greatest common factor? So what's left over? Well, from the 90, I took away a 3 and a 5, so there's a 3 and a 2 left over. And 3 times 2 is 6. I have 5 x's and I took away 3 of them, so there are 2 x's left over. X squared. I have 4 y's and I took away 3 of them, so there is 1 y left over. I'm done. There's nothing else left over. Minus. So then I'm moving on to my 45. I took the 5 and the 3 away, so what's left over? 3. So we start with our number 3. I have 3 x's, I took 3 away. I don't have any x's left. I have 5 y's, I took 3 away, so I have 2 left. Plus, in the 30, I took away the 5 and 3, but there's still a 2 left over, 2. I have 4 x's, I took 3 away, so there's 1 left over. I have 3 y's, took all of them away, there's nothing left over. Plus, well, I took everything away from the 15, I took everything away from the x cubed, I took everything away from the y cubed, I took all my x's, all my y's, all of the 15. So what's left over? Remember, when we take the whole term, what's left over is always just 1. So remember, when the term equals the GCF, 1 is left over. Now, my last step is to ask myself, is there any further factoring that can be done? In other words, is this a difference of squares, a difference of cubes, a sum of cubes? Is it a quadratic polynomial? Is it a cubic polynomial that can be factored by grouping? And the answer in this case is no, it's none of those things. So that means this right here is my final answer. It cannot be further factored, but we checked and we always need to check. All right, hopefully that helped you guys to understand a little bit better what those steps for the greatest common factor were and how to identify and factor out the GCF. Bye.